I just like drawing it as a dash line. Really doesn't matter that much. And the range, as you can see, is from minus 0.25 to infinity. And f of 0 is 2. We can see that here. Okay. Are there any questions at all? Okay, so let's do another one then. Then the one after this, I'll have you guys try, I'll have everyone try as well. And then we'll do something else in this chapter. In this section, excuse me. So let's say we wanted to graph this one. For whatever reason, okay? So what's our A and B, right? We have our A is 1, B is minus 6, C is 5, right? That's really what we want to get first. Then we can use the formulas, which are also in the book. Oh, of course, they're in the notes as well. Okay, so for the vertex, just like in the other examples, right? What we have to do is calculate minus B over 2 times A. We have to calculate that first. Okay, so let's get this quotient. So we have minus 6 over 2 times 1, right? 6 over 2, that's 3. Now for the y coordinate of the vertex, so this is the x coordinate. For the y coordinate, what do? We do f of that, f of negative b over 2a, which is f in this case, f of 3. Plug it in, we get 3 squared minus 6 times 3 plus 5. And that turns out to be 9 minus 18 plus 5, which by direct calculation is minus 4. So we have our vertex, right? The x coordinate. The function values are always the y coordinate. So we have 3 minus 4. And we have the axis of symmetry. Again, that's x equals 3. That's the it's the vertical line passing through the vertex. F of 0 here, right? You just plug it in, you get the constant term, right? Oh, I didn't put the range here. That's all right. Well, let's get the range. We know that A is positive, right? So the graph has to open upward like this, as you can see. Right? Again, how do I know that? Because the A here is positive. Okay. Now, since it's opening upward and the vertex is at the very bottom, so the vertex is, let me see if I can draw this, down here. And from there, we can get the range. Namely, the range is going to be from starting at minus 4, comma, and it goes all the way up, since the graph is pointing up, to infinity. Again, notice I put a square bracket next to negative 4, right? That's included because that's a function value, but I put an open parentheses next to infinity. So that's what we get here. But again, what else do we need? To really get a good graph in the Cartesian plane, we also need the x-intercepts. So again, this one I factored. You could use the quadratic formula. You know, it's still good to factor though. I mean, this case, I think it's easier to factor, mostly because here we have a trinomial, right? 3 terms. The leading coefficient's 1. It's degree 2. Okay, so we want to know, we need 2 numbers whose product is 5 and whose sum is negative 6. Well, how about 5 and 1? No, excuse me, not 5 and 1, negative 5 and negative 1, right? That's going to work. So we get x minus 5 and x minus 1. So this, okay, so we have this is equal to this product. So this product here is equal to 0, right? Because the original equation was. And just like before, each factor you set equal to 0. X minus 5, set that to be 0. X minus 1, set that to be 0. Okay. Okay, that's good. So what do we get? We get x minus 5 is 0, right? We solve that equation. We add 5 to both sides. We get x equals 5. Here, x minus 1 is 0. Add 1 to both sides. You get x equals 1. Okay. So those are the x-intercepts. Now, with the information from the previous slide, we get our graph. Like so. Here's our what do you call it, graph? Here's the arrows on the graph, right? You can see it passes through 1, 0, and 5, 0. X equals 1, x equals 5 are the x-intercepts. 3, negative 4, that's the vertex, right? 0, 5, you know, again, f of 0 is 5. Okay. Trying to draw the axis of symmetry. You only have to draw something or find something if I ask you for it. You know, in the past, I usually don't ask people to get the axis of symmetry. I do go over it though, as you can see. And again, the range is from -4 up to infinity. Okay, that's good. Okay. Do you have any questions on this one? Okay. All right. Okay. I do have another example after this, example 6. Oh, sorry.